Hello, Mr. Betts here. I want to take a look at one example with a separable differential equation that we're going to have to just combine this with some other ideas to solve it. So first thing I'm going to do here is separate the variables just like we do with any separable differential equation. So we're going to have secant squared of y dy is equal to 2x square root of x squared plus 1 dx. And we're going to take the antiderivative on both sides. No troubles so far. Antiderivative of secant squared is tangent of y. Here's where we're going to run into trouble though. Taking the antiderivative here, we're actually going to need to use substitution. So I'm going to go off to the side and I'm going to evaluate this expression right here as side work. So this antiderivative, I'm going to use substitution to evaluate. So I'm going to choose u to be that inside of that square root, x squared plus 1. That makes du 2x dx, and dx is du over 2x. So making a substitution here, we're going to have the antiderivative of 2x square root of u times du over 2x. And conveniently, that 2 was there, so that cancels. And this is just the antiderivative of u to the 1/2 du. So then that will be u to the 3/2 times 2/3. So that's using the power rule there, plus c. I do want to put the plus c in here. Even though this is side work, I want to make sure I'm doing things correctly. And then finally, I'm going to plug back in the expression with x in it. So it's going to be 2/3 x squared plus 1 to the 3/2 plus c. And so that right there is what's going to go on the right side. Now, just a quick note on notation. Had I brought this expression down and not evaluated the antiderivative, technically I should put a plus c here and then equals the antiderivative, all this stuff. I would recommend just evaluating that antiderivative as side work so you don't have to worry about plus c's. And so that way we're taking the antiderivative on both sides at the same time, and our 1 plus c on the right side will take care of both. So we get 2/3 x squared plus 1 to the 3/2 power plus c. And then finally we need to get y by itself, so we're going to use arctangent. And that plus c does need to be inside of the arctangent function. And there is our general solution.